Now in exercise 9C, the only variation we're introducing is we're going to move the vertex away from the origin. Now, you saw with the parabola, if you moved the vertex of the parabola away from the origin previously, then you had a translation. You saw with a circle, you could move this center of the circle away from the origin. We called it a translation. That translation concept applies here as well, and algebraically, the way you coped with the translation is also the same here as it was. So we know that if the vertex moves from 0, 0 to say hk, we're going to simply replace the x with the x minus the h and a y with a y minus k. So that nicely just fits into our go-to formula, which was previously x squared is 4ay. Now if we've got x minus h all squared, 4ay minus k, then we know that the vertex, has become h and k. So now this is almost like the complete version of our geometrical definition of a parabola, because from this we can see if we ensure we've got our equation in this form, and by the way, that must be a single y in there. So if it was a 2y for some reason occurring, you must take the 2 out, and you'd have to adjust your constant if there was one, and so you're dividing everything by 2. Just make sure that you're aware that that has to be a single y in that position, and this will almost always be a single x over here as well. In that case, we know that we can read off the vertex as the point hk. We would know the focal length, and by the format we would know which direction that the parabola was in. So an x minus h squared, this is all nice and positive, is going to be up the right way. Still the same concept applies. The focal length is a. The focus has different coordinates. So the focus, you could see, has to have its x ordinate as h, and really the y ordinate is going to be k plus a in this case. So move up to k, but add on the focal length. Everything else, there'll be a variation then with the equation. This will still be y is equal to some constant, but we'll just have to work out the value of a, then work out how many units below the vertex that places the directrix, and then work out where that is relative to the x-axis, and then we can write the equation for the directrix. If the parabola has vertex hk, the axis is parallel to the y-axis, but it is concave down. Now we came across this concept of them referring to the axis. If the axis is parallel to the y-axis, it just means it has the y-axis, or x is equal to 0, and it's parallel to that. So it's like it's a U-shape or an upside down U-shape, as opposed to a parabola on its side. If it has a negative in here, what we know is it will be upside down. So now what this format of the equation enables us to do is read the vertex, realise it's upside down, and hopefully we can either calculate the focal length from the equation, or from the diagram we can work out the focal length. So how would we draw this one? Well, we know that we would have an upside down parabola, and we know that this is going to be the vertex, which is H and K. The focus is still the focus. The focus is in here somewhere. Our directrix is out here. It's again a horizontal line. Y is equal to whatever that focal length would be. I think that's about all there is to say about that. Now, moving on to the other orientation for the parabola, in that it's a parabola on its side. So its basic equation was the y squared is 4ax. Now you can see that when the vertex moves from here at the origin over to here, then we call that vertex HK, and it features in the equation. Now notice how it features in the equation. Because the k is the variation of the y, then the k, it's y minus k all squared. And h is the variation on the x values, and it's still x minus h. So it still is, you replace x with x minus h and y with y minus k, but just be careful that you do actually put those values in the right spot in the equation. This again is another test of how good you are at paying attention to detail. Now, paying attention to detail is, like I've said before, something everyone really can do. It's not that it's overly complicated. It's not complicated at all. It does require training and an awareness. Being aware of paying attention to the detail. That's why I say for many of you, don't take shortcuts. You're missing the detail in what's actually going on, and some of you are making mistakes and getting lost there. So we want to pay attention to every little detail and practice it in every aspect of our mathematical working. So we know that we've got h and k appearing in those positions, and likewise over here, this is a y squared, again parabola on its side, and it's now going in the negative direction. And if this is h and k, then h is the impact on the x, k is the impact on the y, and they're the positions that they hold in the equation. Focus would be in here somewhere. Axis would be a different axis. It is parallel to the x-axis, but it might have its axis have the equation y equals -1 or something. I suppose it'll depend on that k value. It'll have the directrix, and its directrix will have an x equals equation. I'll stop the video there and do the examples in another video.